friends, welcome to my channel Interesting Engineering. Today in our video we are going to discuss about rectifier type instruments. So we have already discussed about PMMC, MI and electrodynamometer type instruments. As we have seen earlier, PMMC instruments are meant for measuring only the DC quantities, whereas the MI and electrodynamometer type can be made use of for both AC as well as DC quantity measurement. So these rectifier type instruments are meant for measuring AC quantities, particularly voltages in the radio frequency range of measurement, that is from 20 Hz to 20,000 kHz. So why we choose these instruments are, it has major two advantages, that is it has less loading effect so that it consumes less amount of power from the source side. That is, normally when we make use of any instrument, it should not acquire lot of power for its operation. That is the major advantage of this instrument. Whereas when we say about these MI or electrodynamometer type, they consumes much power for its operation. Whereas this rectifier and PMMC instruments consumes less amount of power for its operation. That's the major advantage of this instrument. So these PMMC also have the same advantage, but we can't make use of this PMMC instrument for AC measurement. That's why we go for this rectifier type of instruments. So the major parts involved in a rectifier type instruments are the rectifier unit and the PMMC instrument for indication purpose. Rectifier unit converts this AC input into unidirectional DC, and that DC source operates this PMMC instrument. So whatever the input, the AC input we are applying here can be indicated by making use of PMMC instrument. That's the constructional feature of this PMMC rectifier type instrument. But since here we make use of a PMMC instrument, it can record only the average values. That is, PMMC instrument responds to average values of any current or voltages. But since the input here is AC, we need to make use of for RMS quantity measurement. That is, whenever we make use of AC source, we need to measure the RMS values of currents and voltages. But due to the presence of moving coil arrangement in the case of PMMC instrument, it cannot respond instantaneously for variations. That is, in the case of AC signal, we have variations starting from 0 and it reaches a maximum value, then it go back to 0 position, then it covers in the negative region also. So when we make use of a PMMC instrument, it cannot respond at each and every point of this currents and voltage values. So in that case, we need to convert this AC value by means of some units called the rectifier unit. So in the case of rectifier type instrument, the input here is the AC input, and that input is converted to a unidirectional DC using this rectifier unit, and that is then indicated by means of a PMMC instrument. So here the normal PMMC instruments represents only the average values of currents and voltages. So when we make use of this PMMC instrument for measuring the AC values, we need to calibrate this instrument before making use of this instrument for our measurement purpose. So how to calibrate it? That we can done by means of using this equation, RMS value equal to form factor into average value. RMS value equal to form factor into average value for every AC supply, we need to measure only the RMS value, and whereas the PMMC instrument represents in terms of average value. So before measuring, we need to calibrate this PMMC instrument. So for calibration, we need to find out this form factor value. That form factor varies for every type of waveform entering over here. There are various waveforms available in AC circuits. It may be sinusoidal, triangular, pulsating. Likewise, there are various types of waveforms available in AC circuit. Here we are going to make use of a sinusoidal input. So for sinusoidal input, the form factor varies depending upon the rectifier used. So for half wave rectifier, it has a specific form factor value, whereas when we make use of a full wave rectifier, the form factor differs. So based on that, we need to find out the value of this form factor. So for every indication of this PMMC instrument, we need to multiply it with a form factor value so that we could achieve the RMS value of currents and voltages. That is the calibration done here. So before making use of a PMMC instrument in the rectifier type instrument for measuring the AC values, we need to calibrate this PMMC instrument, and that calibration can be achieved by means of this equation, RMS value equal to form factor into average value. So as I said earlier, this rectifier type instrument have major two parts. Diodes acts as the rectifiers and PMMC instrument acts as the indicating unit. So diodes, in the case of diodes, we can make use of either germanium or silicon depending upon our requirement. So since we make use of germanium or silicon, we can even measure voltages up to 250 volts and currents up to 100 milliamperes. So this is the measurement range of any rectifier type instrument. So when we make use of low current silicon material as a rectifier unit, we can even measure voltages up to 1000 volts. When we make use of low current silicon diode, in the case of rectifying unit, we can even measure up to 1000 volts. This is the measurement range of any rectifier type instrument. So this is about the introduction part. We shall analyze the rectifiers made use of in these rectifier type instrument. So regarding this rectifier type instrument, we make use of a rectifier unit and the PMMC instrument for measuring the AC input. Normally these rectifier type instruments are meant for measuring AC values of voltages. It's very rarely used as a ammeter. When it is used as a ammeter, it's used only for microcurrent or millicurrent measurements. It cannot be made use of for measuring higher values of current. If we want to make use of this rectifier type instrument for measuring higher values of current, we need to make use of current transformer at the input stage, so that the current transformer reduces the current value to the diode operating range, and then we can able to measure it by means of PMMC meters at the output stage. So this is about the rectifier type instrument. We shall analyze the form factor and average voltages values for the rectifier types. There are two types of rectifier type instruments available: half wave rectifier type and full wave rectifier type. We shall discuss about those two types now. So when we look at the half wave rectifier type, so this is the diagram of a half wave rectifier type instrument. So here we make use of a single diode at the initial stage, and we make use of PMMC instrument for indication purpose. So in the input stage, in the initial stage, we can even make use of a resistor here. So that is a series resistor RS, and this resistor helps in reducing the current entering into this PMMC instrument, so that the PMMC instrument can be protected from any sort of damages. So this is about the constructional part. And here, as we all know, half-wave rectifier make use of only a single diode, and at the input stage, if when we pass AC input at the initial input stage, at the positive half will be rectified using this diode, and at the negative half cycle of this input, the diode goes to the reverse biased condition, so that there won't be any sort of output at the output stage. Then once again it goes back to the positive half, so it will be rectified here. So that is the operation of a half wave rectifier type instrument. And normally any PMMC instrument will be measuring only the average values of voltages. So we are going to derive the equation for V average. That is, V average is nothing but average value of voltage at the PMMC instrument here. So here when we look at the output of this PMMC instrument, we have at the negative half there won't be any output. Then once again at the positive half we will be getting output. So this is from 0 to pi, and this is from pi to 2 pi, and from 2 pi to 3 pi. So this is the output of a half wave rectifier circuit. So based on that we are going to derive the V average equation now. So since the entire input starts from 0 to 2 pi, we are going to integrate 1 by 2 pi integral 0 to pi. Since we have output only up to 0 to pi stage, we are integrating only up to 0 to pi Vm sin omega t d of omega t. That is the AC input. The input entering here is the AC input. So we are going to make use of the equation as Vm sin omega t. So when we integrate, Vm is constant, take it outside, Vm by 2 pi. Integration of sin omega t is cos omega t within the limits of 0 to pi. So in the next stage I am going to apply the limits. So cos pi plus cos 0. So minus of minus will be plus, so I am writing plus over here. Then applying the lower limit cos 0, so I have written cos 0 here. So Vm by 2 pi, cos pi is minus 1, minus into minus plus side. So here plus 1 plus cos 0 is 1, so 1 plus 1 2, 2 and 2 gets cancelled out. So the resultant will be V average equal to Vm by pi. So since here we have 1 by pi, after simplification we get it as 0.318 Vm. And then since this is Vm represents the maximum value, we need to calculate for RMS value. So RMS value Vrms or V equal to Vrms equal to Vm by root 2. So I am substituting this over here. Vm, instead of Vm I am replacing it by root 2 into V. So that will be V average equal to 0.45 into V. So this is the average voltage for a AC rectifier circuit. So this rectifier, half wave rectifier will be having only 45% of output for the AC input compared to the DC input. So for a DC input it rectifies the whatever in RMS value that is obtained that is applied over here will reach this PMMC instrument, whereas in the case of AC input only 45% of this input enters into this PMMC instrument, and it is being displayed there. So in the case of half wave rectifier unit, we make use of a single diode, and source is the AC source. So in this AC, when the input is AC, the instrument will reach only 45% of its input. So that's why V average equal to 0.45 V. So when we calculate form factor, for calibration purpose, we need form factor value. We need the instrument has to display RMS value, but this instrument will be displaying only the average value. So based on the average and form factor value, we can calibrate this PMMC instrument. So we are going to find out form factor now. Form factor equal to RMS value by average value. So RMS value is nothing but Vm by root 2, and average value I have written as Vm by pi. V average equal to Vm by pi. So we on substituting here, Vm and Vm cancels out. So pi by root 2 is nothing but 2.22. So whenever we make use of a half wave rectifier type instrument for measuring AC values of voltages, we need to calibrate this PMMC instrument by multiplying with a constant of 2.22. So this is about the half wave rectifier unit. So in this half wave rectifier unit, we can even extend the voltage range of this PMMC instrument by making use of some sort of modifications in the circuit. So IF is nothing but IFS is the full scale deflection current. So that is the current required to make a deflection of full scale value. So that is that we can also term it by means of another term called sensitivity. So sensitivity is nothing but 1 by IFS, which is nothing but and its unit is ohms per volt. Since 1 by IFS we can write it as V by R. So since it is 1 by IFS, it will be R by V. That's why its unit is ohm per volt. So I am going to write it as IFS equal to the entire voltage entering here, that is V, and all these resistances are connected in series. RS is the series resistance, RD is the resistance of diode, and RM is the meter resistance. So since all these resistors are connected in series, I am writing the current equation as IF is equal to V by RS plus RD plus RM. So we can find out the value of RS, that is the series resistance value, can be modified to extend the range of this meter. So to find out the value of RS, we are simplifying this equation. So it is V by IFS minus RD minus RM. So V by IFS, since here we have 1 by IFS. 1 by IFS is nothing but sensitivity. So RS is equal to V into SDC. This S is sensitivity, SDC minus RD/RM. So here, when this is made use of for AC quantity measurement, RS will be equal to this SDC is 0.45 SAC. SAC will be 0.45 SDC into V minus RD minus RM. So by means of which we can even increase the range of this meter for our measurement purpose. So this is about the half wave rectifier, and we shall see about the full wave rectifier circuit. In the case of full wave rectifier, we make use of a bridge circuit. So in the case of bridge circuit, we have 4 diodes. So at the positive half, here also we are going to apply AC input. So during positive half cycle, the diodes D3, the current enters through D3, goes to PMMC instrument, and then it goes to this D4, and then it go back over here. So at the for the positive half cycle, this diode D3 and D4 will be conducting, and during negative half cycle it enters through D1, then it goes back to the PMMC instrument, then it goes to D2 diode, then it go back to the input here. So for a AC input during positive half cycle, diode D3 and D4 will be conducting, and during negative half cycle, diode D1 and D2 will be conducting, so that the output waveform will be like this. So for the positive half cycle, diode D3 D4 conducts, so we have the output here, and for the negative half cycle, diodes D1 and D2 conducts, so we have the output over here. And similarly for the next positive half cycle, diodes D3 and D4 will be conducting, so we'll be getting output over here. So that is the operation of a full wave rectifier circuit. So here too we make use of a resistance, series resistance, to limit the current entering into this PMMC instrument. As usual, we are going to find out the average voltage. So average voltage equal to 1 by pi integral 0 to pi Vm sin omega t d omega t. So Vm is constant, I am taking it outside. Vm by pi, integration of sin omega t is minus cos omega t within the limits of 0 to pi. So when we substitute the limits, we get it as 2 Vm by pi. So when we simplify this, 2 by pi will be 0.636 into Vm, and when we want to find out, instead of Vm, I am going to substitute the RMS value, so it is root 2V. So when we multiply these two, we get it as V average equal to 0.9V. So the instrument, PMMC instrument here, will show a 90% of output when we make use of AC input. So whenever the input is AC, at the output stage, we will have a 90% of output. So that is the V average value, and similarly the sensitivity for AC input will be 90% of sensitivity for DC input. Similarly, we are going to find out the form factor now. So form factor is meant for calibrating this PMMC instrument. So form factor is nothing but RMS value by average value. RMS is Vm by root 2. Average is, here what we get as average is Vm by pi. So it will be 1.11. So this is when we want to calibrate this PMMC instrument for measuring AC values of voltage. We need to multiply the values of PMMC by means of a constant 1.11. So when we want to extend this instrument for higher values of measurement, we can make use of this equation. So IFS is nothing but full scale deflection current is equal to the current voltage entering here is V, and we have resistances RS, RD and RM series. So at any stage, two diodes will be conducting at any instant. So I am writing it as IF is equal to V by RS plus 2 into RD plus RM. So the series resistance equation, we can derive it like this: V by IFS minus 2 RD minus RM. So 1 by IFS is sensitivity. So V into SDC minus 2 RD minus RM. So suppose this instrument has to be used for AC measurement, we can make use of it as RS is equal to V into SAC minus 2 RD minus RM. So SAC is 0.9 SDC, so I am substituting it here. So 0.9 V SDC minus 2 RD minus RM. This is how we can extend this range of this instrument for higher values of AC voltage measurement. So when we make use of rectifier type of instrument, we can achieve 45% of output at the output stage in the case of half wave rectifier unit, whereas we can achieve 90% of output in the case of full wave rectifier unit. So now let's see about its advantages. So these instruments have a higher frequency range measurements up to 20 hertz to higher values of frequencies. It's for measuring higher voltages, it requires only little amount of current. That's why the current operating range is lower for voltmeters. It has a uniform scale and its accuracy, it has a higher accuracy also. So regarding the errors, in the case of this rectifier type instrument, there can occur error due to two main reasons. Since we are calibrating this PMMC instrument for different types of waveforms. Initially we found out the form factor for sine wave, and when we multiply those form factor with the average value, we could able to achieve this instrument for measuring the AC values. Similarly, for every type of waveforms, the form factor differs. So once we calibrate the instrument with a particular type of waveform, we cannot make it for measuring with the other type of waveforms. That's the major cause of error in this instrument, and there occurs error even due to temperature variations. Due to variation in temperature, there occurs variation in the resistance values of diodes, which could add up in the output stage also. So that may also even cause error in the measurement values. Regarding its application, this instrument can be used for measuring voltage ranging from 50 to 250 volts. By using this rectifier type instrument, we can measure voltages up to 250 volts, and these instruments are meant for measuring lower values of currents in the range of microamps or milliamps, and it is also used in the communication circuits for measurement purpose, that is in the audio radio frequency ranges circuits. So that is the major application of this instrument. So with this, this is about this rectifier type instrument. So any rectifier type instrument make use of rectifiers for rectification purpose, and at the output indication purpose they make use of PMMC instruments, and these instruments are majorly used for AC quantities of voltage measurement. For measuring current values, it's rarely used. When it is used for measuring higher values of currents, the current transformer is introduced in the measurement side. So this is about the rectifier type instrument. In our next video, we shall see about induction type instrument. So for more videos, keep watching. Please subscribe and share. Thanks for watching.